Hello class, today we're going to be implementing a stack data structure completely and entirely in C. It will be dynamic and it will not require any kind of, static allocation or linked list. I don't believe those work in the long run, so we're just going to make it fast and do it right the first time. First, we're going to start off with our stack structure. So we're going to type def struct. We're going to need our data. This is our data type. The actual long, the type that it's pointing to does not really matter. You can make that a char. You can make that exactly whatever you want. It doesn't really matter. This is all perfect for caching, so everybody's happy. And we'll name this stack. Just stack. It's simple. In our push method, we'll need our stack type passed by reference or by pointer. And we're going to need a data type. So just name it value. To start, we're obviously going to need, this is the simplest way to do it, but it's wrong. Stack data at stack size is equal to value. This is kind of the centerpiece here, but we need to make some things certain before we do that. So we need to make sure there's enough size. Manage your memory with perfection and perfectionism. Required size is obviously equal to stack size plus 1, because we're adding one thing. So if required size is a power of 2 realic. How do we check for that? Well, a great way to check if a number is a power of 2 is by saying n and n minus 1 is equal to 0. This is the simplest way. Now, obviously, there's going to be some issues there. However, conveniently enough, with required size, we do have two numbers that are 1 away from each other. So we will simply, if required size and stack size is equal to 0, realic. Now this realic statement is going to be a bit of a thing to wrap your head around, but first we have to fix this bug that I'm sure some people have already caught on to. It would have allocated, or it would have interpreted this as a bitwise AND against these two numbers, which would not have been good. So stack data. So this is the actual data pointer assignment, not the values themselves. Equals realic stack data. What we'll need is size of long times 2 times required size. I know that's quite a bit, but I promise you this works. So now we just need to increment our stack size, and this function is complete. We go into main and we say, oh, I want my stack. Let's get our stack out of numbers. That's what I'll name it. And we'll set the data equal to null, just to show that you can, and this is how you should allocate this. Size is equal to 0. And we're going to push to the stack of numbers I could type, that would be great. Stack of numbers, and just the number 5. Pretty simple. See if it compiles. It does. It runs just fine. So now what we'll need is a pop function. This is pretty simple. I'm going to keep it as simple as possible because it doesn't really need to be any more complex than just stack size and then decrement it. I mean, doesn't get any easier than that, right? You will always want to free your data. So at the end of everything, make sure you call free on your stack of numbers dot data, because this was allocated on the stack. It's not a pointer. Let's get a peek function in here. So we're gonna have long peek. Stack pointer stack, and this will just return stack data at stack size -1, because the size is always going to be one more than the index, right? And we don't have any checks in here. You could make this a lot safer if you had checks like if stack size is equal to 0, blah, 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 blah. But you don't really need that if you're being responsible. Just make sure you're being responsible, of course. And you can kind of see here just how fast this gets. We're going to go up to 6 hexadecimal digits in length here. Going to push to our stack of numbers, just I. We're not going to be using any. Ooh, I did have a bug in here. Okay. I forgot to say return. That was silly of me. Yeah. I mean, it's really as simple as that. You don't need any complex structures, or I mean, maybe you could have some generic typing in here. I don't think it gets much simpler and faster than this. You don't even have to deal with capacity. You can keep scaling on these digits as long as you want. It's just fast. It's just fast and it's just simple. Exactly how I like it. This concludes the lecture.